The topic for the day is trigonometry, or in short, trig, which is one of the interesting topics that we've learned and then we want to go over. The word trigonometry is derived from a Greek word, trigonon. A Greek word, trigonon. Trigonometry. It is derived from a Greek word, trigonon, which is trigonon and metron. The meaning of these two words, trigonon and metron, meaning triangle measurements. Triangle measurements. Triangle measurements. So it means that all that we are going to do today concerns a triangle, but it's going to be a right angle triangle because we have so many triangles. But if we are dealing with trig, it means that we are talking about a right angle triangle. Now, in a right angle triangle, first, let's make identification of the sides. The longest side of a right angle triangle is always the hypotenuse. Hypotenuse. That is the longest side of a right angle triangle. Then, students, we are left with two sides to name. What name is given to this side? Whoever makes an attempt of answering will get it wrong, because after naming the longest side being the hypotenuse, the other two sides cannot be named. What's the reason? The reason is very simple. Unless the angle is marked, we can't name the other two sides. So let's mark the angle. Let's put theta here. Now that we have marked the angle, it means we can go ahead and then name the other two sides. So the other two sides, this side becomes the adjacent. The adjacent. And then the other end becomes the opposite. Becomes the opposite. Now, how do we help the man on the street to ask for the longest side? As soon as a right angle triangle is drawn, identify the longest side is very simple. How do we help the man on the street or somebody who doesn't know what you know to identify, find the difference between the adjacent and the opposite? This is how we should help the man on the street. Assume the angle theta is now marked here. This place is hypotenuse. Then, to locate the opposite, because everything that is going to be done, you need the correct identification of the sides. So to help the man on the street to identify which side is the opposite, is the line when erased does not affect the angle. So when we erase this line, it won't affect the angle. So that line which does not, when erased, does not affect the angle becomes the opposite. So this time round, this line or this side is the opposite. This means that this end has now become the adjacent. Right. So now we know the three sides, we know the hypotenuse, we know the opposite, and then we know the adjacent. Good. Now, after knowing the sides, we are dealing with three things as far as trig is concerned at your level. We are talking about sine theta, we are talking about cos theta, and then we are talking about tan theta. These are what is going to be put together as far as questions are concerned. So let's now find what we call the identities, the trig identities. Let's now look at them, or the ratios, how to simplify things as far as questions concerning trig is concerned. Let's see how we are going to put things together. Now, we can now simply, as soon as the angle is marked, this is hypotenuse. We now know this side is opposite. We also know that, and this end is the adjacent. Good. Then we are now going to use the sides to derive things connected to sine, things connected to cos, things connected to tan theta or tan. We start with 1, the first one. The first one, sine. Now the angle is marked theta, so we say sine theta. Sine theta is opposite over hypotenuse. Opposite over hypotenuse. So this is opposite, we represent it with O, and the hypotenuse is represented by H. That will give us sine. That will give us sine. So sine is opposite over hypotenuse. Now, when we add the first letter of sine theta, it is SOH. So for the definition of sine theta, we'll write SOH. Later, we'll come back and put them together and then form a very nice acronym, so that anytime we want to memorize or we want to recall, we will be able to do that. The second one is cos theta. I've already said we are dealing with three things that will form the trigonometry at your level. Sine theta, cos theta, and tan theta. These are the only 3 things we are going to put together to see how questions are answered. So cos theta is adjacent, which is represented here by A, over hypotenuse. If we pick the first letter of cos theta, it is C. So CAH. Let's write that one, put it there, CAH. Then the last one, or the third one, is tan theta. And tan theta is opposite over adjacent. So O over A. Now in the same way, if we pick the first letter, this is T O A. So we get T O A. So we get TOA. We get T O A. Now, the best we can memorize this, or let's joke with it. We say that the trig ratio form an acronym which is popularly called SOHCAHTOA. SOHCAHTOA. Let me hear you. SOHCAHTOA. The ratios are popularly called SOHCAHTOA. SOHCAHTOA. Let's joke with it in the memory form. Anytime you want to find any of the trig ratios, we should remember SOHCAHTOA. Now that we've identified the areas, we've got the trig ratios, which is popularly called SOHCAHTOA. Let's see how we should find a given angle. Let's start with this. Let's mark this angle theta. Theta is what is popularly known in our spheres. Now, let's put 5 here, 4 and 3. I want us to do something. We want to find something, why certain things is happening. It's the same angle, but we are going to define that angle theta in terms of sine, cos and tan, and then we find why it is so. Now, if you want to write sine theta, it is opposite over hypotenuse. That is so opposite over hypotenuse. And then there's the opposite. Opposite is 4. And then hypotenuse is 5. If we were to find the sine inverse of the angle, this implies that theta is sine inverse of theta is equals to sine inverse of 4 over 5. Now, when we click this from our calculators, sine inverse of 4 over 5 will give us something. Do it and let's all see. Now, let's define cos also. So theta, cos theta, which is adjacent over hypotenuse, which is adjacent. So here adjacent is 3 over hypotenuse, which is 5. Now use your calculators and then let's find the angle. So cos inverse of 3 over 5. Put it there. Let's find tan also of the same angle. Now, tan theta, which is opposite over adjacent. Opposite over adjacent. Opposite over adjacent. So opposite is 4. And then the adjacent is 3. Let's find the angle of it. Let's find the tan inverse of the angle. So theta will also give us tan inverse of 4 over 3. Now, we can all see that though we have different fractions for sine, a different fraction for cos, a different fraction for tan. But when we find their angles, all of them will give us the same answer. I want somebody to help me. Why is it so that we have different fractions for sine, a different fraction for cos, and a different fraction for tan? But when we go to the calculators and then we find the answer, all the answers are the same. Who can tell us? Thank you. Yes, they are the same because it is the same angle that is being defined in terms of sine, in terms of cos, and then in terms of tan. It's the same angle, though we have different fractions. Good. Let's continue. Now, let's have this figure and see what's the import of the question and see how we can use SOHCAHTOA to find what we are required to find. The question goes this way. In the diagram below, say find the sum of x and y. Find the sum of x and y. Let's see the figure. This is the figure. We have this place being 90. As soon as we see this there, we know it is a right angle triangle. Another one is also here. Then we have this angle to be y. And then this one too is also x. We have root 3 here. This is 1 unit. 2 root 3, and then we have 4. Then we have 2 here. Good. We are going to find the sum of x and y. So we have two triangles being put together to form an amalgamated figure, but we can clearly see the 90 for the one on top and then the 90 for the one below. So the 90 will help us to identify the adjacent, the opposites, and then the hypotenuse. Therefore, let's find the value of x by considering the triangle at the down part of the figure. Let's consider that one. We have all the three sizes, so it means that we can use any of the three ratios. Any of them can be used. Now we started with sine, so let's use sine. If you want to find sine x, we are saying that, remember, it is SOHCAHTOA. So as soon as it is sine, S is what leads the acronym sine, and sine is opposite over hypotenuse. So when we go to the figure, the first figure down there, opposite is 1, and then the hypotenuse is 2. So we have 1 over 2 as the value of sine. Now let's go ahead and then, if we want to find the cos of it, if you want to find the cos of the same x, this also equals to cos x, which is adjacent over hypotenuse. And here, the adjacent is root 3 and the hypotenuse is 2. So we'll have root 3 over 2. So any of them, we can use any of them for the purposes of what we want. Now, let's find the sine inverse of half and then sine inverse of root 3 over 2 and see if they will be the same as far as our definition is concerned. So we have x, sine x is equals to sine inverse of half, which is the same thing as cos inverse of root 3 over 2. Now let's go to our calculators and then find sine inverse of half and then cos inverse of 3 over 2. If we get the same answer, then it means that our SOHCAHTOA is working. Sine inverse of half is 30. Check cos inverse of root 3 over 2. We also have that one to be 30 degrees. So we have got x from two definitions. We could have added tan, but because of time, let's use the two of them to find that one. Now, let's find y. So to reduce time for y, let's now use tan. So we say tan y. We go back to the acronym SOHCAHTOA. So if you are using SOHCAHTOA, then it means that it is, when we see t, it is followed by opposite over adjacent. So when we go to the second, y is found in the second triangle, whose dimensions are 4, 2, and then 2 root 3 are the dimensions. So we want to find the opposite of that one if you consider y. So the opposite, as I said, is the line. When you raise, will not affect the angle. So if we clear this line, it will not affect y. So it means that the opposite is 2 root 3. 2 root 3. And then adjacent of the one on top is 2. Therefore, if you want to find y, let's find the inverse of that. So tan inverse of 2 root 3 all over 2. Let's go to our calculators and find tan inverse of what we have there. And then that one, 2 will cancel the 2, and then we find tan inverse of 3. Tan inverse of root 3 will give us 60. Therefore, the question says that we should find the value of x and y. So therefore, x plus y is 30 plus 60. And this will give us 90 degrees. So we were asked separate values, and then afterwards we have been asked at the tail end of the question to find the sum. So that is 30 plus 90 will do. Let's see our second question. We will be applying the SOHCAHTOA. That forms the basis of what we are doing. So our third question also goes through this. Let's draw this figure. We have two figures in one shape. Because of we needed some identification, let's name them. The angle given is 60 degrees. This side is 20 centimeters. This end from P to Q. From P to Q, we have 6 centimeters, and then between Q and R is X centimeters. It's X centimeters. Now, the 90 is shown always because the right angle triangle that we are dealing with, the 90 is supposed to be. Now, let's get the question involves this figure. Let's get the question down. In the figure above, PS, that is the magnitude of PS, is 20 centimeters. PQ is 6. Is 6 centimeters. QR is X centimeters. QR is X centimeters. And then angle SPR. Angle SPR is given to us as 60 degrees. Use this information to answer questions 1.3. Use this information to answer questions all right. Now let's see what the 1.3 is requesting from us. The 1.3 says that we should find the value of x. So 1.3 say find x. Find x. So let's see. The x is the magnitude of Q and R, or the distance between Q and R. Right. Let's see how we'll be able to find that one. Looking at the triangles given, we have PSQ and then SQR. SQR is within the domain of what we are doing. And then SPR is also within the domain. Why? Because both are right angle triangles. But we could see that SPQ is a triangle, right? But it's not a right angle triangle. So it means that it will not fall within the domain. So we should do everything to avoid it. Good. Now, we wanted to find x. We have the angle that has been given, and then we have 20 centimeters. We can now identify them. The longest side, as when we identify the size, is known to be the hypotenuse. Then, if the angle is identified or is marked as 60 over there, then it means that PR will also be the adjacent. So now that we know two of the variables, it means that we can easily find x. We can easily find x. So when we have hypotenuse, if we have hypotenuse, we are dealing with SOHCAHTOA. We have hypotenuse, and then we have adjacent. It means that what follows next will be C. That one will be cut. So we'll be dealing with cos. We'll be dealing with cos theta. So cos theta is defined as cos theta. So instead of theta, we are putting down the angle, which is 60 degrees. and then that one is which is adjacent. So adjacent here is 6 plus x. We don't know x, but from the definition of SOHCAHTOA, when we are defining cos theta is always adjacent to our hypotenuse. Therefore, we have the adjacent to be 6 plus x, 6 plus x, all over h, which is the hypotenuse, which is 20. Good. So it means that we are now solving for x. So let's do cross multiplication. We'll have 20 cos 60 equals to 6 plus x. Now, I want somebody to help us. Use your calculators and then point cos 60 times 20 or 20 times cos 60. Let's see what we'll get. So we'll have 20 times cos 60. We did it somewhere, it is half. So we have 20 times half is equals to 6 plus x. Then half of 20 will be 10, which is equals to 6 plus x. Therefore, to find x, x is equals to 10 minus 6 is equals to 4. So, without touching triangle SPQ, without touching that one, we have managed to get x going through the definition SOHCAHTOA. Let's see what 1.4 also requests from us. We say we should calculate the length SR. Calculate the length SR. Calculate the length SR. (1.4) calculates the length SR. SR. This end up to that end is what we are going to find. Now we know the value of x, so things are very easy for us now. So it means that PR is 6 plus 4, making it 10. So if we consider PS, that is the hypotenuse, and then PR will now become the adjacent. So if we want to find SR, it means that SR will become opposite. SR will become opposite. So if we go to SOHCAHTOA, when we have been asked to find the opposites and then we know hypotenuse, it means that we'll be going for sine. Yes, we have this, and then we have been asked to find this one whilst we know sine. So it means that we'll be going for sine theta. Therefore, we say that sine theta, or this time it is sine 60. Sine 60 is equals to opposite. Opposite is the SR we have been told to find. SR is equals to hypotenuse, which is 20. Therefore, SR is simply going to be 20 sine 60. And then this, in a revision class, clicking this one on your calculators is very simple. So multiply 20 by sine 60. Therefore, SR will be sine 60 will give us root 3. Sine 60 will give us root 3, and then we'll multiply that one. So RS will be 20 sine 60. 20 sine 60. 20 sine 60. So 20 sine 60 will give us 17.3 centimeters. We could have find SR from different domain. Yes, we calculated for x, which is 4, and then we also know the hypotenuse. So whilst we are dealing with a right angle triangle, we could have also used Pythagoras theorem, which would have also given us the same answer. So if we suppose we are not sure, and then Pythagoras theorem, we started learning that one from our early stages, and then we want to be sure that Pythagoras theorem will also give us the same thing. Let's see. If we were to consider Pythagoras theorem, then it means that SR or PR square plus RS square should be equals to SP square. That is from Pythagoras theorem. That is from Pythagoras theorem. Good. So PR is now 6 plus 4, which will be 6 plus 4 square plus RS, which is not known. RS is what we are now looking for. RS is not known, equals to SP, which is 20. So that one will give us 20 square. Good. So let's make RS the subject. So RS is equals to RS square is equals to 20 square minus 6 plus 4 will now be 10 square. Then with the help of the calculator, we find square root of both sides. So RS will be equals to root 20 square minus 10 square. Then we can click it and then get the answer straight. Therefore, RS is equals to 17.3 centimeters as we have. So this was used as a check. Suppose we were not sure, we could have also gone through this from another side of the story. Now let's see question 5. This time round, we are going to be giving the figures, all right, and then we may be asked to find either the sine inverse or the cos inverse. So let's see the next question. Question 5 says that f sine x is equals to 1 over q. Which of the following equals to tan x? Which of the following equals tan x? This means that if we have sine x being equals to 1 over x, we have been requested to find tan x. That is the import of the question. We have been requested to find tan x. Now we should note one thing. Anytime we have three things coming together to form trig, so the trig ratios, anytime we are giving one of the trig ratios and then we are being asked to find the other one, immediately Pythagoras should come in, because trigonometry does not go on its own. It's always with Pythagoras theorem. So anytime one of the trig ratios is given to us and then we are being requested to find the other trig ratio, it means that we should not forget that we draw the right angle triangle and then Pythagoras should come in, help us to find the other end before we'll be able to find the other trig. So let's draw our right angle triangle as usual. Then this time the angle is not theta, it is x. So we've marked the angle. Now that the angle is marked, clearly sine theta is still so, what is opposite over hypotenuse. So opposite is 1, and then hypotenuse is q. Therefore, we have been told to find tan. So it means this side is not known. Let's put k there, and then find k. When we know k, it means that we can still go to that theorem SOHCAHTOA, and then we use the values that we found to define tan x. So with this, let's use Pythagoras theorem. So from Pythagoras theorem, we'll have k square plus 1 square, which equals to q square. Therefore, we are making k the subject. So k square will be equals to q square minus 1 square. Let's put it 1 square now. Then we now want to find k. So k is equals to, we are taking square root of both sides. So square root of q square minus 1 square is 1. Therefore, we have got k to be root q square minus 1. Then we go back to the popular acronym that we have for our study of trig, which is SOHCAHTOA. Now we know all the sides, so let's go and use the definition. Let's go and use the definition. So tan, which is opposite over adjacent. Opposite over adjacent. So with this, our opposite is we want tan x, and here our opposite is 1, and then the adjacent is now root Q square minus 1. So when we follow the acronym SOHCAHTOA, anything that is given to us as far as tan is concerned, we'll be able to solve it within some few minutes. Let's see more questions. Let's see more questions, because the more we do, the more we understand. Let's see the next question. The next question says that if sine theta, f sine theta is equals to 3 over 5, find the value of tan theta. Find the value of tan theta. I've intentionally repeated what was done so that we will see, we will follow it. We have already said that if one trig ratio is given to you and then you have been told to find another one, immediately Pythagoras theorem will come in, because we are dealing with a right angle triangle. And then the first man that who introduced something about the right angle triangle we know is Pythagoras. So anytime we are dealing with something that connects with a right angle triangle, then we should not forget about him. So let's draw. First we draw. Second, we mark the angle. Here the angle is theta. So we put theta here. Theta could have been here, but to make things very simple for us, let's maintain it where it is. Now, so it's opposite over hypotenuse. Then we have said that opposite is a line. When you raise, it will not affect the angle. So clearly this is the opposite, 3. Then the longest side is hypotenuse, which is 5. Then clearly we might need to find the other side. So let's put x there. We don't know, an unknown, so let's put x there. Now let's come back and find the value of x before we go and define that of tan. So with Pythagoras theorem, we'll have x squared plus 3x squared equals to 5 squared. Therefore, x squared will now be equal to 5 squared minus 3 squared. So x, we find square root of both sides. 5 squared minus 3x squared. And this could easily be manipulated from your calculators. So 25 minus 9 will give us 16. We take the square root of that and then we will have 4. So clearly we've got x to be equals to 4. Now that we find the value of x, we can now define tan. So therefore, the requested answer, which is tan theta, will be equals to TOA. Always refer to the acronym. So SOHCAHTOA, we have heard of tan, so it is T. It is followed by opposite over adjacent. And here, the opposite is 3, adjacent is 4. So we have 3 over 4. If you want to find the value of it, if you want to find the value of the angle, then we say that theta is equals to tan inverse of 3 over 4. Then theta, go to your calculators and help me get the answer. We have 36.87. 36.87 degrees. Because it's an angle, we can even end the answer by saying it's approximately equals to 36.9. But when it is left in this, it means that we know what we are doing. Let's find, let's now move away from sine and then go to the other side of the coin and see. We want to get more questions as basis so that the problems connected to trig, which we see to be very simple, with the usage of the acronym SOHCAHTOA, you overcome every problem. So our next question, the question says that find the angle alpha in the ratio in the right angle triangle below. Find the angle alpha. Find the angle alpha in the right angle. In the right angled triangle below. This is the figure. And then we have 8 here, we have 5. This is the right angle triangle. And then this is alpha. Good. So when this person is given to us, we still go back to the acronym SOHCAHTOA. Now we ask ourselves, which of the sides have been given to us? That's the question we have to ask ourselves in order to find alpha. The sides, the identification of the sides, 8 is hypotenuse, that's the longest side. And then we are saying that the line that has got nothing to do with the angle is also opposite. So here we have hypotenuse, that is 8, and then we have opposite being also 5. So it means that the trig ratio we are looking for is sine. So we say that sine alpha is equals to opposite, which is 5 over hypotenuse. Therefore, we have been told to find alpha. So alpha is equals to, we find the inverse of the ratio, which is 5 over 8. So help me with your calculators. Just point that one, let's see. We'll have alpha to be approximately equals to 39 degrees. So with what we want us to memorize, that is the SOHCAHTOA. Anything that we want to do as far as trig is concerned, we cannot take it out. More questions. Let's see our next question. The next question says that we should find the angle theta in the diagram below to the nearest degree. Find the angle theta in the diagram below to the nearest degree, to the nearest degree. So let's see the figure. Right. Now this time around we have seen where the angle is marked. We still don't have a problem. We are saying that to identify the various sides, the longer side is always the hypotenuse. Now the line that has got nothing to do with the angle is the opposite. So it means that if this place is the opposite, then it means we have hypotenuse and then we have the adjacent. So if you have hypotenuse and the adjacent, it means that we are dealing with ka, which is cos. So let's still go to the acronym SOHCAHTOA, and then we have cos theta, which is adjacent, and this time around the adjacent is 12, so it is 12 over 13. Therefore, the angle theta, which is the cos inverse of the ratio, 12 over 13. Therefore, we have theta to be equals to yes, you can help me. That is cos inverse of 12 over 13. We'll have 23 degrees. We have 23 degrees. All right. Now that you've got now that we have got the basics, in our next lesson, we'll learn how to use what we've done just now to find fractions, to find how to calculate, use sine, cos, and tan to solve questions connected to fractions. Thank you. When you go revise and revise so much with the acronym SOHCAHTOA, learn the size that we are saying that the angle or the line that has got nothing to do is the angle. Thank you.